Hi, and welcome to this week's update for the enclosure. It has been a bit of a better week compared to last week. I still have some muscle strains and back issues, but my team is working to put me back together. But we did get some work done, including this trap primer system. I've got 4 drains in the basement, and the purpose of a trap primer is to ensure that the water in the P-trap never dries out, allowing sewer gases into the home. Normally, a system is installed that senses a drop in water pressure in the cold water line, and when it does, it sort of dribbles a little bit of water into the trap. My plumbing inspector is not a fan of the devices. I certainly noticed that when I was doing home inspections, they fail frequently. They can easily plug up. So he had originally suggested I put a T on the riser to the master bedroom shower. Every time that the shower was used, a small pinhole off of the T would distribute some water down into the traps. But then he also approved using the non-potable water that I'm collecting in the cistern from the perimeter drain piping at the bottom of the foundation, so that we don't have to put potable water down the drain. So in order to do that, I've got a cistern pump that would run anytime there was a drop in pressure. So if I didn't have some sort of valving mechanism here, the pump would just continually run and continually put water into the traps, which would lead to fairly high energy bills. So what I'm going to be doing is putting and you just see it here, a landscape irrigation valve that I'll put on an automation circuit with my home seer automation system. And it'll come on like once a month and for a couple minutes, and feed water into the trap priming system. Now this trap primer distribution hub has been mounted upside down. I don't want to get a lot of angry posters. I'm not mounting it the official way. I just do not have room based on the limited floor depth, floor truss depth here. And I didn't have a spot upstairs that was a reasonable place to mount this so that I could gravity feed these trap lines. Each of the 4 PEX goes to a floor drain trap primer. So I'm mounting this upside down. I did test it. It does work good enough to put enough water into each of the 4 circuits. But one of the main considerations is that this trap distribution hub is not meant for mains pressure. And as a result, I'm going to need to step the pressure down to roughly 20 psi or a little bit lower before it enters this hub so that it doesn't blow apart. This part here, this bottom piece here, is just friction fit with an O-ring into the body above. So I am going to put a pressure regulator before the zone valve or the landscaping valve to bring the pressure down. All of this still has to be insulated, and the PEX, the purple PEX that you see in the background is the non-potable water source to these primers. And obviously I'll insulate all of those once I've fully connected up the pressure regulator into the system as well. I had quite a bit of issue doing the plumbing connections to this hub. Those 4 copper tubes ended up being what I came up with. I went through a lot of grief, just not thinking ahead. I was trying to mount a fitting directly to the gray hub that was then crimped to the white PEX. And as you can see here, it's a tight grouping, and obviously once the fittings are screwed into the hub, there was no way of putting the crimper onto the PEX line. And once it was crimped on the PEX line, there was no way of screwing that into the hub. So I had to add 4 copper stubs that could then be connected via compression fitting down into the hub, which is what I figured out after many hours, way too many hours and too many trips to the plumbing wholesaler. So that was the first task that got completed. The next task that got completed was prep for all of the electrical panels and the PV inverter and the relays that are going to drop some of the load when on generator. So the first plywood backer for the main panel is this one that you see here. And it is a long piece of plywood, because you'll just see it, and I'll get through the shadow here in a second. You'll see a line down there. That is going to be the bottom of the panel. And that is going to be the top of the panel, way up there. It's a 66 circuit panel. And what I'll do is I'll come over this way so we can see a little bit better. And there is no allowances for large panels on the required height of the top breaker. The handle of the top breaker cannot be more than 1.7 meters from the floor, no matter what the size of the breaker panel is. So it basically means the bottom breakers I'll have to get down on my hands and knees to work on and hook up, and could easily hit them as I'm walking by with my knees if I'm not careful. But all of the panels are going to be mounted to these 3/4 inch plywood backers. I've made the opening quite wide so that I can nicely staple the incoming circuits and make it a nice, neat, professional looking job. This existing panel is what I originally thought could supply the house. I think it's 40 circuits, and I am the better part of 60 circuits that I'm going to need for this dwelling. And quite frankly, the panel that I'm wanting to put in from Leventon, if I can figure out how to pay for it, wasn't around when I started building this house. So this is going to end up being just a construction panel. It's coming out, and instead I will put in a service-rated generator bypass switch, an automated bypass switch that'll be fed with the 200 amp tech cable coming into the dwelling. You'll probably notice that these pictures are a lot more stable. My friend who is a cinematographer, he's worked on episodes of The Bachelorette, and he's in BC. He's also worked on border security and whatnot. Anyway, he has lent me one of his handheld gimbals, which is this automation motorized system, 3-axis motorized system. So no matter what I do, it keeps the picture nice and smooth, and I'm revolving this quite a bit, and it's just gently floating. And so, for instance, as I turn it from side to side, you'll notice that the picture is nice and flat, horizontal. Anyway, so that's what's improved the picture a bit. The next panel that got mounted is the photovoltaic inverter. This converts the DC current from the rooftop photovoltaics into alternating currents that will be fed into the main panel. So let me just explain a little bit about my backup generator system here. In a lot of homes, the generator is sized quite small and is only meant to service a very small number of circuits. which means that the majority of the house is dead. It's not that much more money to put in a larger generator, and it means that in a power outage, I'll be able to have all of the lights on, the computers on. The computers will still probably have internet connection because often the Cablevision and the Telus internet provider system has battery backup within the neighborhood, and often they're not on the same grid and don't get hit with the same outages. It also means that I'm going to be able to do things like cook, which is going to be really nice. It's probably a couple $1,000s more for the generator, and the transfer switch maybe about $500 more. So it's a nice feature that doesn't really cost a lot of money. But because of that, I needed the service-rated transfer switch that's going to go in first before the main circuit panel. Now back to the PV. The PV inverter gets mounted to the circuit furthest away from the main panel's main circuit breaker. So the main circuit breaker is going to be up at the top, which means that the PV circuit breaker is going to have to be way down at the bottom. The next item that got installed is this relay box that I talked about in my last update. This is going to be what drops two 100 amp circuits for the the metalwork and the woodworking shop subpanels, and it'll prevent the generator from being overloaded by too much load, because the shop represents huge loads, more than a normal house combined. I obviously need to be able to reduce that so that the generator isn't needing to be huge. Another panel that got installed, I'll just walk down to where the shop is. This is the woodworking shop. There's the, you guys saw that earlier, there's the cedar tree slabs. Anyway, there is the sub panel for the woodworking shop, and that'll feed all of the lights and all of the equipment. Fortunately, the building code identifies that when you have a home shop, you're still one person. So even though you have machines that together could probably add up to 200 plus amps, you're only going to be using one main machine and maybe your dust extraction system. So it doesn't require you to size the panels for the whole load. It recognizes the fact that you're only going to be using one thing at a time, which is obviously a benefit to me. What else? Let me just get my wits about me, and I'll go through the next item in a sec. So the next grouping of items were all related to finishing off some construction work that needs to be done prior to starting the plumbing supply and electrical circuits. One of the items was this partition wall, interior partition wall, and I'll just scan up here if I can. And it was to rebuild the wall so that it went right to the ceiling. Initially, my HRV plan had some of this ducting extending into the stairwell circuit or stairwell opening in behind. But we reformatted where the ducting was going as I was doing the ducting installation, and as a result, I now needed to extend this wall up so that it could be secured to the underside of the floor trusses. One of the other items that got completed This is not the best example, but wherever there was an interior partition wall that was perpendicular to an outside wall. When I first started building the house, I had intended to do airtight drywall approach for my air barrier. I was going to have a continuous piece of drywall that went through that gap so that it was easier to create that air barrier, which is why there's that half-inch gap there. So I had to go around and secure the perpendicular wall to the exterior wall by filling in the gap with plywood before securing. Now this particular partition wall, I did not have a choice as to how it was framed. It's a outside inside corner of the exterior that an inside perpendicular wall faces, and let's go someplace where it's easier to explain that. And I'm just going to give you a little bit of a spin back down. There we go. I love this gimbal. Anyway, so this is the other side of it. It was an outside corner. So I didn't have a lot of choice as to how, obviously, that was framed. But if I go to another location where we have a inside wall meeting an outside wall. There's one back there, but there's a better one here if it's not going to be too dark. It's going to be too dark, so let's go over to this one. I chose to not frame these so that there was a stud behind the end of the perpendicular wall. I wanted to reduce the thermal bridging, and this is the standard method of doing so, where you place an exterior wall stud on each side of the perpendicular wall with then cross blocking that you attach the perpendicular wall to. So it means that there's a limited number of locations where the perpendicular wall is touching the exterior wall and introducing a thermal bridge. And it allows for continuous insulation behind that. Obviously the blocking they're 2x3s, you can barely see them here, and they're on their flat, so there's still an opportunity to put some insulation in behind. Another item that I completed was securing all interior braced wall panels to structure below. The requirement is that the bottom floor plate of all braced wall panels, and braced wall panels are a seismic requirement to prevent racking of the building. They have to be secured to framing below on a 6-inch center. And if you don't have a 6-inch center, then you have to make up for it with additional nailing on the wood structure below that you do have. So in this particular case, I measured the length of the wall, divided it by 6 inches, and came up with a number of fasteners required. And then where I did have a set of a structure that I could attach it to, I would add the required fasteners to each location to make up for the total number that I needed for the whole wall. And that's instructions provided by the engineer, and obviously it's best practice. So I went around, I've got a few braced wall interior panels, not many, because I do not have heavy construction. I do not require a lot of interior braced wall panels, but another one was the wall between the dining room and the office, which is plywood clad over there. It's plywood clad instead of just drywall, because it is an offset for the fact that the upper floor is further inboard from the lower floor, and it's called orthogonal setback, And one of the requirements is to have a plywood-clad interior braced wall band on the main floor and the basement. Below where, within a certain distance, and I can go into that at some other time. Or if you're interested, send me an email and I'll post an update on that specific topic. So I did go through and fasten all of the braced wall bands to framing below. I also finally finished framing above the first floor bathroom door. I had left that open because we were trying to find a way to put in a full 36-inch wide door to meet Saver Homes requirements. But this stub wall from here to here is actually part of, it's a braced wall panel, and it had to be a minimum width, which is exactly what this is, which means that I'm going to have to make this a 34-inch door. So with that, I finally framed the header above it. I also put in the blocking required for exterior doors. They require blocking at the latch, which is the one that you see here. They also require blocking at each of, sorry, that's just a reminder to check on my neighbor who was silly enough to drive to Alberta on this weekend of snow and rain. Anyway, they require the blocking at each of the hinge locations as well. And that is just to prevent somebody from bringing a crowbar on the outside of the building and trying to separate the structure away from the door. So they could put a crowbar right in that gap on the outside and try to pry it this way in order to get the door open. So it prevents that from happening by attaching it to the next stud bay. Okay, so I still have a little bit of blocking to do and framing to do before I can do the electrical plumbing in the kitchen. I'm going to have a drop ceiling in the kitchen. Which is obviously why I was able to do the drop duct work that you see here. So I've got that to do, and I've got some bulkheads around some of the ducting that you see in behind in that mudroom. But otherwise, then all of the construction will be 100% complete and ready for electrical and plumbing supply. Now, speaking of plumbing supply, I did install the drain water heat recovery unit, which is this copper coil that you see here. So it gets mounted to the ABS drain stack. Just a compression fitting at both ends. Now, what I didn't account for, and I'll go around to the other side, I didn't account for the fresh water, the cold water supply to that unit. And I mean, I don't really have a choice. The drain is where it's at, and you'll see in the background the piece of duct there. That's going to be where the range hood fan is. So I can't really move these studs apart, but it means that I have to have the connections facing out or in, depending on which way you're looking at it. So I'll have to have a little bit of a bump out in the cabinets that are going to be installed over top of this area. Now it's just the mud room, so it's not going to be that critical, but it's just something that hadn't been planned on. And speaking of planning, the other things that I got done this week is more office planning. I was able to go through and do through the structure here, figure out where I'm going to run my hot water and cold water lines, and do a takeoff for all of the piping and fittings that I was going to need, and I have now ordered those, and they should be available either Monday or Tuesday this coming week, and then I'll be able to start installing the water supply system. So that is what got done this week. As I said, it was better than last week. It could be still better. I had probably a full day and a half that I was dealing with the back, going to appointments and stuff like that. But it's getting better, and I'm able to walk quite a bit better now without too much pain. But hopefully next week will be even better. So bye for now, and as always, thanks for visiting.